Find the value of this square root without using a calculator. But where should we start the solution? To solve this question, I'm going to start with this inner part that says square root of 49 minus square root of 48. As you know, 49 is a perfect square, so square root of 49 is going to be 7, and square root of 48 is going to be, but 48 is not a perfect square. Right, 48 is not a perfect square, but it can be written as a product of two numbers, 16 and 3. So here we go. Welcome to Maths with Teacher MJ. In this video, I'm going to solve this fun little math problem. But before I start the solution, please feel free, pause the video, solve it yourself, and compare your answers with my solution. Remember, if you use different way to solve this question, please let me know. It always makes me happy to see how creative you guys can be. So I'm going to start the solution after 3 seconds. 1, 2, go ahead and get us started. To start the solution, let's rewrite this inner part that says square root of 49 minus square root of 48. Right. Square root of 49 is 7 minus square root of 48 can be written as a product of two numbers, 16 and 3. 16 times 3. Now to continue the solution, I'm going to get help from a rule that says this rule. Square root of A times B is going to be square root of A times square root of B. Right. Now I'm going to get help to continue the solution. 7 minus square root of 16 times 3 is going to be 7 minus square root of 16 times square root of 3. Until here, we did it well, but it is really easy. What should we do to continue the solution? We have 7 square root of 16 and square root of 3. As you know, 16 is a perfect square, so it can be written as the product of 4 times 4, and the square root of 4 times 4 is 4. So let's continue the solution and rewrite this as 7 minus 4 square root of 3. Now, we have 7, we have 4, and we have a square root of 3. Here we need to be clever and find a solution. To continue the solution, I'm going to write 7 as the sum of two numbers, 4 and 3. Right, 4 and 3. 7 can be written as the sum of 4 and 3. Let's do it. 4 plus 3 minus 4 square root of 3. What is the next? 4 can be written as a product of 2 times 2 or 2 squared. Right. 4 is 2 squared. And 3 can be written as square root of 3 squared. So let's see what happens. First one, 2 squared plus square root of 3 squared minus 4 times square root of 3. Now, can you guess what is the solution? We have 2 squared, square root of 3 squared, and here 4 times square root of 3. What should we do? Right, 4 can be written as a product of 2 times 2. Let's do it. 2 times 2. It's going to be 2 squared plus square root of 3 squared minus 2 times 2 square root of 3. So what is this? Look, first term squared, second term squared minus 2 twice of the product of the first term and second term. Can you guess the solution? Okay, let me help you more. I'm going to change the place of this term and this term. So it's going to be 2 squared minus twice of the product of the 2 and square root of 3 and square root of 3 square. But what is this? Now, I'm sure all you can guess. Right. To continue the solution, I'm going to get help from an algebraic identity that says a minus b squared. Square of difference of two terms is going to be first term squared minus twice of the product of the first term and second term plus second term squared. Look, first term squared minus twice of the product of the first term and second term squared. So it's going to be 2 minus square root of 3 squared. And this is our inner part. Now we are going to put this inner part in our original expression. Let's see what happens. We have square root of 49 minus square root of 48 is going to be 2 minus square root of 3 squared. Right. To continue the solution, these two as exponent, these two as root cancel off. So it's going to be 2 minus square root of 3. Until here we did it well. Great. It can be our answer. But if you can't find this in our options, we can continue the solution. As you know, square root of 3 is same as 1.732, right? So 2 minus 1.732. What is 2 minus 1.732? It's going to be 0.238. And this is our final answer. So remember, if you use different way to solve this question, please let me know. It always makes me happy to see how creative you guys can be. Have fun.